bear with me just one second. So just to make sure we're on model 6. I'm sorry, we're on module 6, model evaluation, just to make sure for the recording that that's super clear. And we're in the model evaluation phase of the pipeline. And we are, we're going to be using our test set as our final kind of evaluator about whether or not our model, after it's trained, is to test the predictive quality. We're taking just a little bit of a deviation to just confirm the understanding of overfitting and underfitting. And the reason this is important is because fit is going to help us determine and understand the root cause for poor model accuracy. Okay. So this understanding will help you figure out what corrective steps to take. Like, do you apply some regularization and reduce the flexibility? Do you need more dimensionality and richness in your data? This is what underfitting and overfitting are going to help you figure out, right? So what you can do is you can look at the prediction error on the training data and the evaluation data. So your model, by the way, is going to be underfitting the training data when the model performs poorly on the training data, because this is really like where everybody starts. The model is really unable to capture. So this is the one in the middle, underfitting. The model is unable to capture the relationship between the input examples and the label that you're shooting for. Your model is overfitting if it does well on the training data, but it doesn't do well on the validation data, which is not the test data set, it's the data set that you use to correct and reinforce the training data, right? But if you're doing well on the training data and your validation data, it doesn't perform well, that's because the model's memorizing the data it's seen in the training data, and it's still not able to generalize into unseen examples. So poor performance on the training data, by the way, could be because the model is too simple, meaning that the input features are either not expressive or representative enough to describe the target outcome well. And so what you can do is that if it's underfitting, you can do this by increasing the model flexibility, right? So you can add more domain-specific features to the data, change the type of feature processing. You can change like the n-gram size and the variety of images, and you can decrease the amount of like regularization or kind of control that's used, right? Like limitations on like hyperparameters and data variation. If your model is overfitting on the data, which means that it's like memorized the training data and it's performing poorly on the validation data, you kind of want to take actions that reduce like the model flexibility, right? You could use fewer features. You could decrease, in other words, the opposite of what you were doing for underfitting. You could decrease the number of attribute, like numeric attribute bins, right? You could increase the amount of regularization. In other words, limit the amount of steps that it takes, limit the size of changes that it could make, right? So accuracy on the training and the test data could be poor because the learning algorithm didn't have enough data to learn from, right? So that's a whole kind of different set of things. Is underfitting and overfitting have to do about how well you're doing with the training data and the validation data. If you're doing poorly on both those sets of data and the final test, you probably just don't have enough examples of data to learn from. Either that or your test data has a bunch of data in it that there are no even similar samples of that test data, like that are similar to that in the training or the validation data. Now, how do you fix that? You can either increase the amount of data in the data set, which isn't always possible, or just increase the number of passes on the existing training data. But especially if you find out that you have samples in your test data and there's no representation for those samples in the training data, you might need to mix the data up a little bit more and then resegment it. So those are all possibilities. But bottom line, here's what I want you to memorize. Please memorize this. If you are underfitting, you need to add more domain-specific features and more richness to your data, and you might need to change the types of feature processing used. And you want to decrease regularization. Now, you might be hearing regularization, and you're like, I don't know what that is. Just stay with me for a second. Underfitting, you're going to add more features to your data set, and you're going to decrease the amount of regularization used. With overfitting, you're going to consider using fewer feature combinations, decrease the number of like numeric attribute bins, that kind of thing, and you're going to increase the amount of regularization used. So underfitting, right? You're going to decrease regularization because you need it to be more flexible. With overfitting, you're going to increase regularization. Wait, is that right? Yeah, hold on. think I might have got that right. Yeah, no, you're going to increase the amount of regularization with overfitting because you want to basically decrease the flexibility. You want to reduce model flexibility. So just remember those like words for now. They may not have a whole lot of meaning to you, but we're going to talk about some statistics that can help that make a little bit more sense. Okay. So the bullseye, by the way, is a great analogy for how we could look at this. So because the center of the bullseye is really kind of where you're targeting, right? That's really where we're wanting to go, right? Because it predicts the value of your model. In other words, are your predictions matching reality? Awesome. Reality is that red bullseye. Now, each dot is a result, like a prediction that your model produces during training. So you can see what we've got here is that we've got low bias and low variance, which is the ideal in the upper left-hand side. Over on the right-hand side, you've got low bias and you've got high variance. And on the lower left, you've got high bias and low variance, and you've got high bias and high variance, which is the worst in the upper right-hand side, right? And you can probably guess you want low, right? But there's a balancing act here. I usually see systems where you can increase the bias, but variance doesn't really want to. Sorry, you can decrease the bias, but then variance goes up. You decrease the variance, and then bias goes up. Sometimes that happens, but ultimately, you're trying to go for a minimized prediction error, not bias or variance specifically. That minimized prediction error, that's a combination of this bias variance trade-off, right? So here's the deal. If we want to bring underfitting and overfitting back in the picture, underfitting, let me pull out my annotation tool just to make sure we're calling this out. I don't know why I'm having trouble, but I am. Yeah, there we go. Cool. All right, underfitting, by the way, bring underfitting back in the picture. Underfitting is when you have low variance, but you have high bias. So this is underfitting, right? You've got low variance and you've got high bias. Everyone follow me? Underfitting means this guy is not making, generally, by the way, it's not making good predictions, right? And it might even be precise, like it's clustering things together really well. There's not a whole lot of variance around it. These models are overly simple if they're underfitting, and they really can't see the underlying patterns, right? And yeah, so you need to expand their flexibility, feed them more data, give them more variation. You need to train them better. This is a problem with training. Overfitting is high variance. This is overfitting and low bias, right? So this is overfitting right here. These models are overly complex, and while they can detect some patterns in the training data, right, they aren't really accurate outside of the training data, right? So obviously the worst case is this, where you've got a model that not only never hits the target, but it guesses badly and it guesses widely, right? At least here, again, this is horrible too, because it never hits the target, but it is actually clustered together. This sometimes hits the target, so your predictions are right, but it's got this huge variance described to it. So, right, in terms of like which is better, an overfitting model is probably slightly better than an underfitting model, because a overfitting model will actually occasionally hit the target. If that makes any sense? This one is the worst, right? Which means that you've got a model that just has a tremendous amount of bias, and it's not consistent about how it makes predictions either. How do you get to that one? That one's unusual, actually. I don't usually see that. You see a model that just cannot figure out how to respond to the training data, or I see a model that thinks it knows too much about the training data, but it's spread all over the place. That's overfitting, by the way, the last one. Does anyone ever explain this differently? Anybody else want to add any color to this from the student body, from you guys? So remember, low bias, low variance is our ideal target. Hard to get there sometimes. Okay. So we've got relatively low bias, maybe some high variance. That's going to be overfitting. If we've got high bias, right? But, low variance, right? Can adding more data alone take a underfitting model into high bias? I was about to say, I'm not sure, Dakota, adding more data, can it take it into low bias? Can adding more data alone take it to low bias? Well, remember, we do want it to make accurate predictions. So hopefully the more like relevant data that you give it, the more it learns and the more it is able to make accurate predictions. But that isn't always the case, right? But yeah, typically adding more data in some cases, or like more meaningful data, like not just more data, but more meaningful data, obviously, as part of your pre-processing, will typically train the model so it can get closer to the actual reality. So the right data will actually get it closer to a lower bias, meaning it has a lower, like a more alignment with reality, with less variation. Because remember, those variations, it's the combination of bias and variance that causes the issues, right? You want it to have low variance, meaning it's very consistent about how it's targeting, and low bias, which means it's actually not being thrown off. It's actually like going towards where reality is. So more of the right kind of data can actually do that. Chris, high variance is if your data does well for the training set, but poorly on unseen data sets, such as a test set. I think that's accurate. Yeah, because that's pretty much the definition of overfitting, right? Does well on the training data, but doesn't do well on the validation data or the test data. Yeah. Yes, that's a good point also, actually. If I'm training someone to shoot, that sounds kind of weird, doesn't it? But I do live in the South. If I'm training someone to shoot, I actually like to see the high bias, low variance, the one on the lower left-hand side, because it means that their process to shoot is actually super consistent. The way they get there yields the same precise results. The problem is that their accuracy is off, right? And so at that point in time, it's just a matter of trying to correct accuracy, because their process to get there is very consistent. They're not deviating with their precision, right? But their accuracy is off because they're not hitting the red bullseye. And so at that point in time, it's just a matter of changing one things. The problem with high variance as a challenge is it means that their process of evaluation, the stages they take to get to the outcome, there's a lot of deviation inside of that. So I like the statements that I've seen. Good. We're gonna keep going. We're gonna stop in like 2 minutes. So high variance tends to be overfitting. High bias means, high variance, you can kind of refer that to precision or consistency, right? It's overfitting. If your predictions are just way off the mark consistently, that's usually underfitting. Obviously, if it's balanced, if it has both, okay? And again, think about bias as the gap between your predicted value and the actual value, whereas variance describes how dispersed your predictions are, okay? So think of bias as the gap, like how accurate are you? Think of variance like as a variation on dispersion or even precision. How precise are you? Okay. We're going to move into metrics that are appropriate for classification problems and for regression problems. I just want to say this is that the exam focuses far more on classification problem metrics than it does on regression problem metrics, because they don't peel out the math. That doesn't mean you're not going to run into, mean squared errors or R squared MSE. You're not going to run into that, but they don't ask you about the math. They just ask you which one is useful for regression versus classification. But they are going to have you do some of the simple math in particular for the classification problem metrics, okay? And that's where I'm going to stop us for lunch, is just that kind of lead in, is that the classification problem metrics are going to have a lot more visibility on the exam than the regression problem metrics, okay? We'll dive into those here in just a second. Okay, so it is currently 12 o'clock. Anyway, have any questions before we break for lunch? Let's see, when you return, we are going to finish out model evaluation, of which we probably got like another 30 or 45 minutes of that. Then we're going to roll into the model training, which is going to take us from pretty much to about 2 to 4. I am going to give extra time for that. And then we're going to cover just maybe at 15, 20 minutes, maybe half an hour of feature engineering just to get you started. And then that's going to be the day. And tomorrow we're going to continue out with feature engineering. We're going to do a lab on feature engineering. That's going to be our last lab, which is pretty much in the beginning of class. And then we're going to do a recap, and then model deployment, and then a post assessment, and that's it. Okay. All right. Yeah, absolutely, Jonathan. We certainly can. Let's do it. Okay, so everyone, it is now 12:01. So let's come back at 1:09. I know, this has just become my favorite number for this class. So 1:09, we're gonna come back, and I'm gonna put up a timer as soon as I finish talking with Jonathan, but just come back at 1:09 and we're good to go, okay? All right, we'll see you. Have a good lunch. Step away from your computer, get some fresh air, take a breath. We'll see you in a bit. Let's see.
Programming occurs in a cave. Fresh air is not what we need.
Well, that's true, but if you step away from your computer, you're not programming, right? You're outside.
You're never not programming. Anyway, everyone's always in sales. Yeah, so I guess my question would be, and correct me if any step is wrong, if you can send me, I don't know if it's a corrected notebook, a new one or something, and then would I go to lab 3, start up fresh and upload that? Or do I just dive right into lab 3 and the notebook's there? What would be the best way forward?
Well, first of all, did you see the message that just popped up on Zoom where I sent you the file?
No.
Are you using a browser or are you using the app?
I'm using Zoom, and flight delay student IPYMB just arrived while we were talking. Perfect. So let me click on it. Potential security. Don't care. I trust you. Let's see if I put it in the download folder, because I don't trust computers. Okay, so flight delay student 1, groovy. So when I launch lab 3, would that be what I would then upload?
Yeah. So what would you do is when you launch lab 3 and you get to that point, you would upload your notebook. And what it would do is that you actually end up, and I'm gonna tell this to the entire class, you actually have to run back through all of the previous cells, because it needs to, because you have to change the bucket, it has to be repopulated. Actually, you change the bucket. I don't think you changed the bucket today. It might be tomorrow. Regardless, you then you re-download all the data, the zip files and everything. You do have to put it in the same kind of like location where it's like just above, it's like in the projects folder, right? And
so let's not we seem to elide by the most important part, the yada yada yada, since your references seem to be very 90s centric. I understand completely. Start from the beginning. I will be going through, but part of the problem was I was in the wrong folder. I assumed that I would want to launch this from the initial folder /data/projects or whatever it is. I can't remember file systems. That's why file systems exist. Do I want to start it from there, or do I need to start it someplace else?
No, you want to be in the projects folder.
Okay. What was wrong with, where do I want to run the solutions folder if I want to test these things, or should I never run out of run the solutions?
So if you want to test the solutions folder, that file actually should be copied into the projects folder. So the solutions notebook should actually be put inside of the projects folder instead of the solutions folder.
Interesting. I thought I did all of my work in data projects. I didn't think I had gone to solutions.
Well, if you open the solutions file, and let me be clear, there were 2 problems. One, there was a problem with the solutions file being in the location. That was one problem. I don't know that we actually figured out what the problem was that you initially started with. So we actually stacked two problems. One had nothing to do with your initial ask.
Mhm.
The second problem was the one that we started troubleshooting, which is why is that not being able to load the HTML file? That was a pathing problem. And that's because the solutions that we both pivoted to, I in particular pivoted to, was in the wrong location to function, because the solutions code should actually be put into the project notebook.
The only thing I'm worried about with the HTML is when I went back, restarted the lab, theoretically, everything should be zeroed out, and only was going through the project notebook, not the solutions notebook, the HTML still would not launch. I could open it by double clicking it in the folder. It would not launch from the notebook. That's one of, I mean, so I don't know if it's a cascade of
Right,
problems.
that was the initial problem, right? That was the one that,
No, the initial problem was that I could never open the CSV files, that once you unzip them, there's that command where you're supposed to merge them all together. That never ran for me. That was the
Yeah.
problem at step one.
well,
And then we started playing around with paths and other stuff and maybe worsened the problem, but that never ran.
yeah. And so when I looked at that, by the way, there was the function definition, which actually didn't do anything. And then there was the setup, which was the next one. And then at the very bottom, it actually called the function.
Except the function has a print statement and it never printed. And then when I would run that one, run the one after and run the one after, it didn't do what it was supposed to do. It crashed. So it, again, it just that anyway. So, but not anyway. That was the fundamental problem, was that statement was supposed to do a lot of work and was done. Say, hey, I'm done. It never got there, gave it plenty of time. And then like, well, maybe there's something wrong. The print statement's not working. I don't know. And then ran them one after. And because the first one didn't work, 2 and 3 didn't work.
Well, just to be clear, the first one wasn't actually supposed to do anything.
The first one was merging all of the CSVs.
But the first one was merely defining the function that did that.
Okay, but at the end,
right? That's what it was doing. It was
well, I
defining
can't,
the function.
as much as I love to memorize under like I really thought that that's where the problem was, because it was, if you're right, it's defining the function. It was supposed to then do something, but there were supposed to be two, we could open it and look, 2 print statements, and they never printed for me at the end of those 2 cells.
Right. And so the third cell is where the actual function was called, and that's where it should have printed out.
But 1 and 2 failed, so 3 failed, regardless.
Well, I don't think you got any output from the first one, right?
I thought it had a print statement, but it doesn't matter. I ran 1, it's supposed to set up a function. I run 2, it's supposed to do something else. 3 is supposed to refer to those 2.
Exactly.
And 3 crashed. It failed repeatedly.
Right. So here's the only thing I can tell you is that, because I remember what the error was for that third step in the process, is that when the solutions code is pulled over into the project notebook as is and ran in sequence, it runs without issue.
Say that again.
When the solutions code is pulled over into the student project notebook and run as is for those 3 sections, it works fine. So I can't speak to, I don't remember the error yesterday.
Yeah, and I don't, that's where, we're, trying to, so if you do, I don't want to take much of your lunch. I'm looking at here at my tabs. I was thinking maybe access the labs. Let's see if it'll let me. Can I?
You can launch lab 3 if you want to, if I activate it, but just
Yeah,
know that it will start the timer for it. I don't remember what the
But it was
timer
6
is.
hours on that one, right?
I think it was 8 hours on the last one, so it might even be.
So
longer.
that should be. Where is my quick labs? I've got so many.
Here, let me send you the link again, if that makes it easier.
Oh, it's WebAge. It should be up from yesterday, but Amazon SageMaker. All right, so wow, it didn't. All right. Sign out. Should have. Now, the one other problem, and again, I'm trying not to focus on problems, but I don't want to keep stepping on rakes. When I quit the lab, went back in, started fresh, it seemed to remember everything that I had done. And so I don't know if they're environmental variables, they're hidden behind the scenes. That's why I asked about clearing my
solution
cache.
did, or the student did,
the
project
student, because I knew that I shouldn't be running at that point the solution. So I'm trying to run the student. Oh, I'll start fresh. Give me that student notebook. But it was like, oh, well, you did this 2 hours ago, not 2 minutes ago. I'm like, no.
Yeah, actually the student section, the project section should be scrubbed because it's literally a new instance.
It
So it'd be
wasn't.
I'm just gonna say this, Jonathan. It's impossible that it remembers it because it literally destroys the lab and starts over.
What?
Right.
Well, if you say about what if it's looking at my downloaded one that I was working on. What if it's in the cache? I mean,
there's no cache, but if you uploaded it, then yes, it would remember.
But I didn't upload it, but it still had the stuff in it. After I quit the lab and opened a new SageMaker instance, I closed the tab and everything. So,
well, let's check it out today.
So all right. So I'm in lab 3. I'm starting the lab. I'm sorry to take away from your lunch, but I will order you a Subway sub to be delivered with the guns that apparently you all have in the South, you monster. I'm from Missouri. My wife is from Richmond, Virginia. No more South bashing.
I'm from the South, so it's all good. And I don't actually.
Why is we have a big old mess of grits and put a catfish on it? Yeah.
Indeed.
Hey, that's just offensive.
Well, that would be more Louisiana, honestly.
Where I'm going to go in 2 weeks for Mardi Gras.
Awesome.
I don't have Omicron yet. I figure that's the best way. All right. And what I'm going to do is, since it takes time to provision, all I want to do is upload, start going through the notebook and just get to that point and have it work. You know, it's funny. It's like I'm nailing all this other stuff. I actually was doing machine learning in college many years ago. We were writing neural nets from scratch. So a lot of the stuff is great. It's like, oh, this reminds me, variance bias and overfitting. That's all easy. The modern coding environment, I hate everything about it. And I hate the fact they try to make it look easy, but it's secretly hard. I hate the fact that we do it in browsers. And I hate the fact that there are so many weird things that are kind of assumed that you spend, as you do, a lot of time solving things like file paths that aren't the interesting part of the problem. The interesting part of the problem is running a machine learning model. But spending an hour trying to figure out if it's an absolute or relative and where am I and why is it calling it this way, but oh, they said it as a definition, is not interesting. But that's where we spent a lot of our time yesterday. And I don't think you wanted that. I know I didn't want that.
Yeah, no, I definitely didn't want that for you. Right. Absolutely. Yeah. I mean, I don't mind troubleshooting, especially if we could get to an outcome, but we didn't. And, you know.
No, but in a sense we did. You spoke to them. They said, oh, we don't intend this. You know, I guess it is funny that I find that the solution notebook doesn't actually give you solutions. It gives you, I'm going to say, a form of pseudocode, because you can't just copy it over.
You can just copy it over. Yeah.
You can or cannot.
You can just copy it over into the project notebook.
Because that was the problem I had where I brought it over and there's an F in front. And like, is that something saying that it's a file vice a link? And I didn't know why there was an F in there.
Yeah, it's just linear substitution. That's all it is. That's just a new Python convention. Right. So,
yeah, but regardless, it didn't work. And then trying to take it out doesn't work. And then I'm looking at the, you know, example code, you know, Googling that. And then as you know, at some point I'm doing programming, which God did not put me on this earth to do.
I understand completely. I totally identify with that statement. And yet we're all having to code. So yeah.
No, I am at the point I'd rather take the whole system down. I'd rather be blowing up data centers and bringing people back to the 1860s. Let's make Zuckerberg pump a well for a while. You know, let's make some butter. I'd rather live in that world at this point. More seriously, you're not going to take our course project files and grade them, right?
No.
Okay. I'm going to continue because I am a highly paid professional. I'm going to continue to put full effort onto this. That's why I want to work on this for a few minutes at lunch, get ahead of it, make sure it works. Oh, there's a 15-minute thing. Maybe I can get to the point where that's running when I go microwave a burrito and whatever. If it doesn't work, though, I'm not going to worry about it, because the thing that I have learned from this, truly, and this is just true, honest feedback, what Booz Allen is doing doesn't make a lot of sense. I understand they want to accelerate people getting advanced certifications, but giving us all 5 weeks to pass a test that is stated that it takes 1 to 2 years of hands-on work to be ready for is ludicrous.
And just to be clear, even if you were we were all experienced data scientists and had done this for the 1 to 2 years, it still takes 60 hours of additional over and above training to pass the exam, which
Right.
usually is done at 12 weeks at 5 hours a week so that your brain doesn't melt down, right?
Yeah. Yeah. So exactly. So what I'm going to do is I'm going to go back to my very nice bosses. So I sort of outlined this to Monday night and say, hey, because I was really worried, because I'm honest to God, I have been graced with all sorts of wonderful gifts. I have the ability to break software like no other human being. I'm surprised Lex Luthor hasn't kidnapped me and had me just walk in banks because vault's open. So I'm like, I was really worried about this. Like, will I not be able to get onto AWS? What will the problems be? What will my Zscaler do? Blah, blah, blah. And I was working through a cloud practitioner, and it was going very well. I'm like, oh, I can get in. Oh, look, I set up an EC2. Yay, it's all good. And I'm going to continue that. And I'm going to take the cloud practitioner exam in a few weeks. And then, oh, if that works out, then that's the beginning of a sensible path where, as you suggested, systems architect. And then if they have me doing some machine learning, or if I keep learning, yeah, machine learning in 6 months. You know, if I'm serious about this as a course of study and I'm playing with it and I'm flashcarding it, but not by March 12th.
Yeah, not by March 12th. That's going to be really hard.
And that. Oh, open console. Sweet. All right. Well, I'm going to let you go. So you get 45 minutes for lunch and you can set up that timer. Well, it's actually almost 50 minutes since you're giving us on the nines, just like the weather and traffic. That joke flies, right? Traffic on the eights, weather on the sixes, class on the nines. And I'm going to play with your notebook because I don't want to drag everyone into troubleshooting again. And honestly, if it doesn't work, I'm going to send it to our team of really sharp machine learners and say, tell me what's wrong with this garbage. And then they'll say, oh, well, this is what's wrong with this garbage. And then we'll fix it.
Okay.
We'll be fine.
Yeah, but just so you know, I had them at AWS look at the rest of the labs and basically, and I ran through all 3 projects yesterday. All of the solutions work when they're put into the project setup. So,
did they fix the problem in the cheat sheet?
Oh no, they didn't fix the problem, but they do know about it, right? They haven't rolled it out. They're actually rolling out a new version today, so they already had one in process.
I mean, come on, string and int. Even I knew that. Come on, that's like you don't microwave hot dogs; they're going to explode. I mean, just cut slits into them. We get it,
right?
Another Southernism.
All right. So it sounds like you got a path. You know where you're headed.
I'm gonna play around, then go get some air.
Cool. All right. Thanks. Yeah. Get out of the cave.
See you in 45. Thank you very much.
You're welcome. See you in a bit. Good afternoon, everyone. Sorry about that. Please excuse my tardiness. Okay. Do we have any questions for anything that we covered in the previous section? Okay. You drop this whole thing. Huh. All right. Model evaluation. All right, here we are. One thing I wanted to check and make sure was going was that all of the labs are pre-warmed. Let's see. We're on lab 3, pre-warmed. There we go. All right, cool. Let's talk about this. When might you customize an algorithm? Well, mainly if you want to use an algorithm that doesn't support a particular like nuance or outcome that you're looking for. But I gotta tell you, like there's like 21 different algorithms out here, if I remember correctly. And I mean, I don't know that I've ever customized an algorithm. Has anyone ever customized an algorithm? And if so, what was your driver for that? I mean, I know what the theoretical drivers are, but what was your actual driver for customizing the algorithm? Has anybody done that? You can hear my voice. I'm assuming everybody can hear me. Yep, it's coming through. Yeah, Frank, Chris, I know why you like possibilities as to why you would, but I don't, and I'll be frank, I don't know anybody who has actually customized an algorithm, at least not in like the public, like the private sector. So I don't have a good reason for that, other than there was something about that you needed to tweak some way that it was approaching the problem. But that's all theoretical. I don't have an actual business reason, right? So. Yeah, so I don't have a good answer for that one. Yes, Chris, that's probably true. Actually, it's not common. Customizing a algorithm for business problems, basically, I've never seen in the private sector. So, especially if you're using one that's already written. So, does that mean essentially writing an algorithm from scratch? No, Devin, what it means is that you are basically modifying an existing algorithm. Writing your own from scratch is definitely beyond the scope of anything that I've seen, right? And that's right. You have to define a bunch of variables and your own metrics and functions for error at that point in time, right? Because they'd have to be modified. If you modify the algorithm, your method of deriving error inside the algorithm would also need to be modified, right? So, okay. So we're going to talk about various aspects such as classification problem metrics and regression problem metrics. We're not really going to dive into the math. It's not what the purpose of this class primarily is, but hold on. Yeah, so that we're going to spend some time basically what metrics would you look at to calculate whether something was successful or not, right? Now, classification problems, typically a confusion matrix is used, which this was mentioned before, but we were actually talking about a correlation matrix, which is about showing the relationships between variables and as far as like positive and negative correlation. Here, what we're saying is that a confusion matrix is basically used to figure out whether, where was it that you made a prediction that something was true and it was actually true? Where is it that you made a prediction that something was actually true, but it was actually false? Where did you make a prediction where it was false and it was actually false? And where did you make a prediction that it was false and it was actually true, right? So a confusion matrix is a way of kind of evaluating, is like evaluating this model for a classification problem. So you see cat, cat, which by the way, cat, cat, right, would make that a what? Is that a true positive, a false positive, a false negative, or a true negative? What are we talking about when it says cat equals cat, right? Good, it's a true positive. That means that what was happening in reality and what you predicted, right? It means that your positive that you predicted was actually true, right? All right, what about where the true value is not cat, but you predicted cat? In other words, you predicted that it was a cat, so it's positive, right? But the actuality, it was not cat. What is that? Right, so just to be in the clear, it was a positive that was false. You predicted a positive, right? Assuming that 1, right, is the positive, is it's a cat. But what was actually happening is that it wasn't a cat. So that's the second line, right? All right, what about the space where you predict that it's not a cat? So you predicted like false, 0, but it actually was a cat. Right, you get a false negative at that point in time, right? Okay, and then let's skip down to the 5th one. Not cat, not cat. You predicted it wasn't a cat and it actually wasn't a cat. What is that? Good. Here's, by the way, what this looks like in a matrix. Please take a moment to just look at this, right? So when we look at this example, right? In this simple image recognition, it's labeling whether it was a cat or not a cat, right? So in the confusion matrix, you get this high level comparison of how what you predicted matches up with what was actually happening in reality. So the actual class runs along the left of the matrix, like, right? These are actually things, right? The predicted class runs along the top. Right, and so because what we're looking for is we're looking for alignment. We want the positives to match, we want the negatives to match, and where they don't, they're false. In other words, the false negative is when you predicted a negative, but it's actually a positive, right? So everything above that line means that those are actual cats. Now, in some cases, your model predicted true positives, which says that you predicted a cat and they're actually cats, but you also have false negatives, which are actually positives, because you predicted a negative, but it's actually a positive. And then the opposite is true on the lower block, where you've got a true negative, which means you predicted a negative and the actual reality was negative. But then you've got a false positive, which means that you predicted that it, right, it was a cat. It's not a cat. So in this case, true positives, right, are where they're both prediction and reality match. That's a great outcome for a model, by the way, right? Where it's what it's predicting and what's the actual reality is great. True negatives are also awesome, right? Just know, by the way, that you might prioritize achieving true negatives in some cases over true positives, or vice versa, depending on what you're trying to classify. For example, if you had cancer, sorry, this is a horrible example, but it's a great one. If you had a life-threatening disease, would you want it to err more on the side of saying you had cancer and therefore you should get checked out? Or would you want it to err more on the side of you didn't have cancer, right? And therefore you might have cancer and therefore, right? In other words, how would you want to, where would you want to lean and focus, right? Your sensitivity and your specificity, which we'll talk about here in a second, right? So just something to think about, right? Is that this is also kind of where this plays out, is that you might actually prioritize to ensure, like either through a score threshold or some other variation, you might say, hey, I want to make sure that we're not telling people that they don't have cancer when they don't, because the cost of not treating cancer, as an example, is worse than emotionally falsely telling people they have cancer. You know what I mean? Coming back to this whole thing, false positive is said where you said something was true, like something existed, like person was a cat, like thing was a cat, and turned out to be a dog. It's It's a false positive, right? So still a negative, still not a cat, but you predicted that it was. Then the false negative says, well, it's definitely not a cat. It's like, well, no, it's a Peruvian hairless cat, which looks like a little bit like a dog. And so, yeah, it still was a cat, actually, right? By the way, if it was an outlier like that, like a Peruvian hairless, maybe you'd exclude Peruvian hairlesses. I don't know, right? So once you apply your model to the, like the testing data, for example, each of these 4 boxes will include an aggregate number of the unique occurrences of, the true positives, the false negatives, and the true negatives. So with these models, with the outcome, you can actually like calculate the model's accuracy, also known as its score, right? You can conduct like accuracy, by the way, by doing this. Now, I am going to tell you this, and I think I said this before. You are going to have to memorize this. I'm sorry, I have no other way to tell you this. This is the deepest math that you're going to have to learn to pass the exam. There's just no way around it. You can't not do it, right? Now, I want to point out that accuracy basically is, in here, in this case, it's the sum of all the true positives and the true negatives, like how accurate, right? Against all of the total predictions that were made, right? Now, this is used widely for classification problems. One thing to put into your brain is that accuracy as a metric by itself probably not as effective as when you combine it with other metrics, right? It is also less effective when there are a lot of true negatives in your data set. Think about the cat, not cat example. If the majority of your accuracy is based on true negatives, all it says about your model is that it could be like really good at predicting it, like what is not a cat. In this case, you can't be very confident in your model's ability to predict cats once you roll it out into production, right? Again, you can modify that by either modifying the proportion or, other changes that you can make to how it evaluates and weights classifiers, right? So think about credit card fraud, for example. If you use accuracy as your main metric, in the case where you have a lot of examples of fraud, but not a lot of examples of positive transactions, which would be really strange because I think you could derive those pretty easily, but whatever. Your really high true negative number might find the fact that your like model's ability to identify fraud cases is kind of less than ideal, right? It's unacceptable to have less than almost perfect performance identifying fraud cases because that would drive customers away, which would be typically opposite of what we want to achieve, right? Now, in that case, by the way, you could tweak it so that the impact of a false, the impact of fraud, like the basically true positive in this case, if you were taking fraud, not fraud, could be tweaked, right? Because remember, in this case, a true positive was you're trying to detect fraud, right? A true negative would be like, these are examples of not fraud. So I realized I said that backwards earlier. Sorry. So a negative means like I've got tons of examples of not fraud. So this is a true negative, and I don't have a whole lot of examples of fraud. If that's too low, then your model is not going to be good at detecting fraud. It's just going to be good at detecting not fraud. Now that I've said it correctly, hopefully that makes more sense. I don't know where the wires got crossed in my brain, right? So think about like where most of your like training set, by the way, 1% of it is fraud examples and 99% of it is not fraud examples. Probably going to have to increase the fraud examples, or at least do some kind of duplication or data augmentation or rerun throughs, iterations in eBox in order to increase that, right? So just the bottom line is that remember that accuracy is typically less effective when there's a lot of true negative cases in your data set. That's the main thing to remember. And it's usually better to couple this with another one, right? That's right, Joel. Same thing that we have with like correlating values inside of a data set that pretty much represent the same thing that moves in lockstep. That is a larger data set that has a particular set of bias in it. And that's why we would reduce the dimensionality or do some kind of aggregation at that point. Same thing. You get a dominant class of data where the true negatives, for example, dominate the data set. That's going to be really hard then for you to be good at predicting true positives. So, well said. Okay. Okay, so this is one you want to remember. This is the sum of all that's true with the sum of everything. Divide everything into the sum of all that's true. Then we got precision. Precision is great when false positives, which by the way are negatives, right? When the cause of false positives are high, right? So this is why, by the way, with that, it's like other metrics are used in conjunction with accuracy. Accuracy basically says, well, sorry, let's talk about precision for a second, which basically just removes the negative predictions from the picture. Precision is basically the proportion of positive predictions that are actually correct. How good at you are hitting the target. Remember this? Sometimes I liken it to variance. It's not always the same, right? To be clear. Precision is the proportion of positive predictions that you made that are actually hitting the bullseye. You can calculate it by taking the true positive and you divide it by the true positive plus the false positives, right? In other words, out of the total positive predictions that you made, how many of those were actually on target? That's what precision is. It says, how many times did you say something was true? Was it actually true? This is combined with accuracy in some cases, which says out of the total number of truths that you made, right? What percentage of those truths were actually part of the overall prediction set? In other words, right? How many times were you actually accurate from a truly positive outcome and a truly negative outcome against the total amount of reality, right? Be nice if it was 100%, right? That means, by the way, you'd have almost no false negatives and no false positives. That's really hard to achieve, just to say this, right? Although you can't get there. Okay, so remember accuracy, right? This is the formula. Precision basically is basically removing the negatives from the picture. How many times when you said something was true, was it actually true? Like consider, like in the notes, it says, like talk about spam, right? So like, if you don't like label like as a spam and prevent your users from seeing that email, when in reality, the email was legitimate, right? So this is great when the cost of false positives is high, right? So, because you don't want to misreport that something is spam, which would be a positive result because you've identified it as spam. You might want to be a little bit more lenient around that because missing it doesn't necessarily have a huge cost, right? So it might be okay if you're like, this isn't spam, so therefore don't put it in the spam folder, don't lock it out, don't put it in the user's inbox, right? So remember, you always have to consider the business problem when you look at like how you're evaluating these models. So you might want to emphasize precision when the cost of false positives is high. This is on the exam. You might want to emphasize precision when the cost of false positives is high. Okay. If you haven't taken notes on that, you probably should. Okay. Now, in addition to precision used with accuracy, there's also something called recall. So in recall, what you're looking at is the proportion of the correct sets that are identified as positive, right? Now, what's interesting about this is that you're basically saying out of the amount of true positives where we actually predicted and they were positive, right? What is the total proportion of true positives out of all of the positives? Because remember, a false negative is a positive, right? So we're trying to figure out how good were we at saying like this is actually true out of the total reality of what was true, right? Which is a little different than we're saying how much of these were true out of the ones that we we predicted were true, right? This one measures the number of things that we got right in total reality, in actual data, right? And this one, out of what we've predicted. And this one basically is doing it out of actual data. Sorry, let me make sure I said that correctly. This one is actually predicting it out of what we predicted. This one's actually doing it out of actual data, because false negative is actually a positive. A true positive is also a positive. That is the reality is that these were positive, and we're trying to figure out how accurate were we in actually predicting against reality. With precision, what we're saying is how often were our predictions accurate, right, around the total amount of predictions that we made. So one gauges against predictions and the other gauges against reality. So with recall, also known as sensitivity, by the way, what we're doing, for example, in this case, is that we're saying, think about like a model where you need to predict whether or not a patient has a terminal illness. In this case, using precision as your evaluation metric doesn't account for the false negatives that are in the model. So in this situation, it's really important not to identify the illness in a patient who in reality has the illness. Because you would rather say, hey, we think you have cancer, go get checked out, than be really strict about it and say, you know what, we're going to lower the line there. And even though you're an educator, we don't think you have cancer. We're calling this situation, which is a better metric to use. Now, you have to memorize that true positives are basically divided by true positive plus the false negatives. In other words, with recall or sensitivity, you are dividing the number of true positives by the number of total actual positives, which includes the true positives plus the false negatives. Because remember, false negatives were real in actuality. They weren't predicted. They were predicted to be negative, but that was false. Because what you're doing is you're dividing the true positives by the total amount of actual positives. With precision, what you're doing is you're dividing true positives by the total amount, right, of predicted positives. I'm not saying whether the false positives are obviously negatives, but you're dividing true positives by the total number of predicted positives. It's a really great way to remember the formula. Precision is true positives divided by all of the positives. Recall is true positives divided by the actual reality positives that were in the data. If this doesn't make sense now, when we do the lab, you're going to pop through it again, okay? So just make sure. You might be like, stick with it. If this is your first time hearing that, you're going to work with it, and you're just going to hold space to understand it and digest it. You're going to memorize the formula. You're going to remember that Michael said that recall is true positives divided by the actual positives that are in the data, including the false negatives and the true positives, and that precision, right, is actually just going to take the true positives and divide them by all the predicted positives. So precision is the gauge about how well out of your predictions you were at basically hitting the target, right? Recall is basically the gauge about out of your total predictions, how many times were you really good at making the prediction versus getting it wrong, right? Yeah. So one emphasizes whether you got it right to a sense, and one emphasizes whether you got it wrong, right? That's why, by the way, they offer that case, because if the cost of getting it right means that you're going to lose access to something like spam in that case, you want to focus on precision, not recall. If the cost of getting it wrong is higher, right? False negatives, like not predicting something as being true, then you're going to emphasize recall. This is where the cancer comes in, right? You're trying to identify whether people truly have cancer. If you falsely say that someone doesn't have cancer, that person's going to get sicker and die because time is the limiting factor there, right? If we catch cancer early, the success rate is higher, right? Good. Yeah, precision is predicted, right? Predication, recall is reality. Good. Okay, we're going to make things more complicated. Okay, so just make sure we're clear. We're about to move just slightly more complicated. Stay with me. I just need you to understand the concepts. I don't need you to rip out the math, okay? Just stay with me. Okay, so now if we want to synthesize Because maybe, for example, precision and recall together are not awesome, or precision and combined with accuracy or recall combined with accuracy doesn't really help us, right? So it doesn't always have to be one or the other. You can actually synthesize these because you can do that with any mathematical value, right? So there's a thing called an F1 score. And what it does is it combines precision and recall together to give you one number to quantify the overall performance of a particular algorithm. You should look at using the F1 score when you have a huge class imbalance, but you want to preserve some level of equality and equity between precision and recall. Okay, so you are going to use the F1 score when you have a class imbalance and you want to preserve precision and recall's value. James, I can tell you right now that because, and this was actually a discussion that was had years ago, because the ML exam forces you to do all the math in your head, they do actually give you relatively easy numbers in your brain, right? Like things will round up to like where 100 is on the bottom value frequently. Don't look for that in the exam. I'm just telling you, because you need to memorize these. I'm just telling you that it was shocking to me how many times true positives and false negatives added up to 100, which then had to be divided into 80, which gave me 0.8, and then that was easy math to do, right? So I'm not saying that they do that consistently, but this was a discussion that was had a few years ago where they were like, well, if we don't have scratch paper and we don't have other stuff, we don't have access to calculators, that's not real life. So if you want to test our knowledge of the formula, then just make it easy for us to at least do the math, right? So just be aware, they're not monsters. They do actually make it possible for you to do it in your head. Yeah, can you imagine if it was like, well, I want you to take 1,265, and then I want you to add 1,265 plus another 586, and I want you to add those together and then divide those into 1,265. Good luck. They don't do that. It's usually under 100, right? Okay, so I would too, and I would too, actually. So F1 score, basically, again, that it's a synthesis. And again, you're going to use this when there's a class imbalance. Main things to remember here. Accuracy is awesome, kind of a good starting point. Not great when there's a lot of true negatives in your data set, okay? Precision is great when the cost of getting something, like saying that something is true and it's really not, false positives, when that cost is high because you're going to exclude the item, that's when this is best when you want to use precision. When saying something is not true when it actually is true, when that cost is high, when false negatives, the cost of false negatives is super high, you're going to want to use recall. I cannot emphasize this enough. You must memorize that when the cost of false positives is high, you're going to emphasize precision. When the cost of false negatives is high, you're going to emphasize sensitivity or recall. You must memorize that. They are going to ask you questions on this. If you want to get them right, you must memorize those conditions. And ideally, you memorize the formula because they are going to have you calculate the formula. Now, in many cases, just so you're aware, they'll put the number in conjunction with the metric you want to emphasize, but you still need to know how to calculate the formula because they're going to ask you to do it and it's going to be in the answer. In other words, if recall is 80 and there's another answer that has recall as 55, how do you know which one of those is right? You can guess, but ideally you know it, right? Because remember, recall is just like reality of what was actually true divided by everything that was true in reality. No, it was mentioned, Devin. It's okay. They do not let you use scratch paper of any type, either in the testing center or in the online proctored. Now, I say that, I don't know when this changed, because I know that last year, because I teach a lot of the local community college and they also have a testing center there. When I took the test there, they gave me a whiteboard and a marker, but then they stopped doing that. I don't know if that was a COVID thing. I don't know. But officially, you're not allowed to have any paper. So I don't know if that was just something the testing center did, but the answer is officially is no.
Hey, Michael.
Yes, sir.
I do have some ways to try and remember some of these because they're so confusing. Mind if I share?
Please go ahead. You want to share your
So if
screen,
we
or
go
you
back to the precision?
Yeah.
So the way I remember precision is that, or the formula for precision is that precision starts with a P and everything in its formula has a P inside of it. So TP, TP, and FP. So
Good.
that's the easiest one for me to remember. When I get to recall, I remember it as the same thing, but the FP just flops. So
Right.
so that's how I remember those two formulas. I basically remember precision first, and I write that one first, and then I write down recall.
Okay.
And to remember which one I use when the cost of something is high, you'll notice that in, say, this equation, there are two TPs and there's one false negative. The one that stands out, so the one that isn't listed twice in the equation, that's the one that you're trying to minimize. So that's the one when the cost is high, false negative is, or when the cost of false negative is high, you want to use recall, because in the recall equation, that's the only one that's kind of the odd one out.
Good. Good. And then in this one, you'd emphasize false positives, and it's also the odd one out, right? So you want to minimize false positives in this case. Is that what you're?
Yep, that's exactly how I remember it.
Good. Good, good, good. And for some reason, people don't have an issue with that, with accuracy. You just take what's true and divide it by everything. So people don't seem to have a problem remembering that one formula, right? Good. This formula, by the way, you do not need to remember. They're not going to ask you to calculate the F1 score. They also, by the way, are not going to ask you to calculate the area under the curve, receiver operator characteristic. They're not going to ask you to do mean squared. They're not going to do any of that RMSE. They're not going to ask you to do anything else. Okay. Good. Anything else, Chris, to add there? Or anybody else, actually?
Not really, although technically that odd one out still works for specificity as well.
Yes. Good. Okay. All right. So F1 score is another one. So thus far we talked about accuracy, precision, recall. We talked about F1 score. Okay. Now, area under the curve is another evaluation metric. So the receiver operator characteristic curve is just a curve of probability. And AUC, as it states here, it just measures like separability. When combined, if you combine probability and a measure of separability together, the curve can show like what the curve is for true positives versus false positives and what they look like at various thresholds. That means that when you calculate this curve, you're going to plot, in a sense, multiple confusion matrices at different thresholds and compare them to one another to find out what the threshold you need is for the business case, right? So this uses sensitivity, which is the true positive rate, plus specificity, which is the false positive rate. Now, let me just say this. Specificity is, I didn't see that at all on the exam, nor is it really listed in the guide, right? So it doesn't get emphasized a whole lot here for some reason. I'm not sure why. But true positive rate is sensitivity, right? Now, notice that recall was also labeled as sensitivity, right? And then there's the false positive rate, which is specificity. So what happens is that when you evaluate this, you can actually look at the area under the curve, right? It's the area under the receiver operator characteristic curve. This basically plots the binary classifier at different thresholds. So the ROC-AUC curve helps in selecting good classifiers. Let's take a look at that in an example. And Keith, hold on. We're going to come back to that. So here, this is the email spam specification, right? So emails are like rank ordered by the classifier's risk score, right? On the left is our high scoring emails. On the right are like the majority of low scoring emails. And here's the trade-off curve. On the x-axis, this axis, not this axis, the x-axis is the percentage of good emails, right? They're not classified as spam. In this case, by the way, right, this is the number of emails that are classified that were actually not spam, that were classified as spam. In other words, this at the bottom, our x-axis, these are emails that got sidelined in the spam folder. On the y-axis is the percentage of spam that we are actually capturing. that knee in the curve is the great trade-off point. So what you do is that you set your operating cutoff at that point. You'll get a good balance, right? That's the 0.687, right? Between the population that we impact and the bads that we capture. Now, there are different costs to that, because if you're like in the security business, you might not want to miss any of those. If you're in a different business, you might be like, no, please do not let any of our users see those. That could be a problem, right? So there are different costs to sidelining a population and capturing the bads versus goods, but you can shift that operating point left to right. And so good classifiers will produce really good trade-off curves, meaning we're going to be really good at capturing legitimate bad email as an example versus like marking good emails as bad. We want to reduce that. Because notice here, I'm going to draw on this just a little bit. So actual spam, now notice that it's like way high, and then it just kind of flattens out a little bit, right? And then down here, we're not falsely, and then we are falsely, and then, oh my God, we're starting to get higher up this range of stuff that we are basically marking as spam when it's not spam, right? So we want to pick a good kind of like area under the curve where we are minimizing the amount of false positives, right? And capturing a really decent amount of what we call true positives, right? We're looking for that trade-off. So this is a good way for you to evaluate your model to find out where you want to be in the curve, right? Like what's going to be the optimal kind of thresholds, if you will, or breakpoints to be in the model. So this kind of shows like how the model like evaluates, right? So if you have 20 models and you get to compare them to see how the models perform against each other, you can figure out whether you want to eat that amount of false positives, right, versus true positives or not. Again, all really dependent on your business objectives. You know, this model, by the way, looks like it's almost like as good as guessing somewhere. It's not, but it looks like it. Main takeaway, right, is that basically using the AUC ROC curve, right, it will allow you to help you to select good classifiers. That's the main thing to take about it. So it is a way of evaluating classification problems. They're not going to ask you to analyze the curve. They're not going to ask you to peel it apart for the most part. They just really want you to know that AUC ROC is actually good for evaluating classification problems. That's the main thing you need to take away from this, at least for the exam. You're going to dive deeper into this, but we are going to move forward just because this is a rabbit hole that can really snare you. You just need to know right now that this is great for evaluating classification models. Let's see, do you have to retrain for each different threshold? Yeah, so when you are defining the curve, you are talking about a different model each and every time. So iterations could fall into this, right, of like training your model. Okay. Could feel some people shutting down. We're going to move forward. Okay. What if you're dealing with a regression problem? So you're not dealing with a classification problem. So you're not accuracy, precision, recall, like, yeah, okay. No, right? Since we're mainly dealing with numbers that derive into a business problem, right? There are other common metrics, right? So mean squared error and R squared are probably the most common ones, right? So mean squared error, and there's the full formula. Again, just shown for giggles, right? Mean squared error is commonly used. Its general purpose is the same as like the classification metrics. What it's saying is that from the model, if we compare the difference between the model and the actual outcome, if we take that, like the difference, square that value, and then sum up all the square differences for all the observations, what is the value that is derived? And can we use that? Because for example, you know, just to say this, is if this is like really high and this is like really high and this is really high and this is really high, you know, et cetera, you're trying to draw a line that is as close to the actual values as possible. And so this is a way of mathematically saying, are we minimizing the distance that we have between these actual values, right? Are we minimizing this as much as possible, right? Because we're looking for something that from a probability standpoint is going to get pretty close, right? Or even be perfect. Now, this holds true not just for mean squared error, or MSE, right? But also for R squared, which is another commonly used metric, right? With linear regression problems. It basically just explains like the fraction of variance for a counted over the model. It's like a percentage. It's a number that usually goes from 0 to 1, which is as it says there, 0 to 1. If R squared is closer to 1, it usually indicates a lot of variabilities in the data that can be explained by the model itself. Good R2s are really actually determined by the actual problem, like the actual business problem. R2 always increases when more variables are added to the model, right? So that's pretty standard, actually. There's also adjusted R2. Takes into the account, by the way, for example, you know, that you've added more variables. So that like when the increases, when they add variables, like they're taking into account that there's more variability because you've added more variables, right? Just because some business problems are really difficult to kind of solve with R squared. And so you can adjust it because you've now added more variables to try and like solve the problem. Because R squared is always increasing when there are more variables added to the model. This can lead to overfitting. So how do you compensate for that from a calculation standpoint? That it doesn't mean that having a higher R squared is always the better model, right? You have to like adjust for the overfitting problem. So just know that adjusted R2 can be used to adjust when you've added a lot more variables into the equation and you want to reduce the impact of those variables for evaluation. So, and remember, right, to counter this issue, there's adjusted R squared is what we're talking about. And it'll take care of the added effect of the additional variables, right? It is in scikit-learn, right? Because remember, R squared is really adjusted R squared is only when it increase when the variables that you've added have significant effects in the prediction. Whereas if you just do R squared and you're not doing adjusted, if you add any variables, it's going to have significant effects. But when you use adjusted R squared, the variables added have to have some kind of significant impact. They have to have a large amount of impact on the data outcome. So it is recommended that you look both at R squared and adjusted R squared outcomes when you're like doing regression, to ensure that your model's performing well and you're not doing too much overfitting. Okay. All right, so here's a question for you. Why might a model perform poorly on training data? Give me a reason why, like, it just is not performing well on the training data. Give me some examples of some possibilities here. Definitely underfit, Keith, so perfect. Right, it's likely the result of underfitting, right? What is the model unable to do? So not enough data, too few features, right? Model doesn't actually represent the training data. Could be imbalanced data, right? But if a model is underfitting, right? What is the thing that's broken between the input examples and the target values? Dakota, perfect. It's because it can't find the relationship. It can't find the pattern in the data, right? It just can't. Now, what happens if a model is going to perform poorly on the validation data? What's the problem then? It's overfit, right? What are some options if you want to fix overfitting? Like underfitting, you can't find the pattern in the data, right? With overfitting, you've got too much of a pattern, right? We got right. We got to regularize you a little bit, right? We got to get more data. We got to reduce dimensionality, right? We have to get some more variability, some more flexibility in the model because you're too tight and you're not making good predictions. right? And let me rephrase that. You're making great predictions against the training data, but when you see data you haven't seen before, you are not actually doing well, right? Good. Okay. If I were going to look at metrics for a classification problem, and I wanted to, for example, emphasize false positives, like I felt like I wanted to minimize false positives, which would I use from a classification standpoint? I want to minimize false positives, right? Okay, good. What if I want to minimize false negatives? Good. Make sure this is super clear. If I want to minimize false positives because they're high, precision. If I want to minimize false negatives because the cost is high, recall, right? Good. Just want to make sure we're clear. All right, hold on. I went too far for that. Okay, good. All right. If I want a synthesis of recall and precision, what's the name of that? If I want a synthesis. Good. Give me one of the three that we just talked about for regression problem metrics. Like if I want to look at regression problem metrics and do some mathematical calculations to see what's appropriate. Give me any one of the three we just talked about. Good. R squared. Well, what was the new one that actually minimizes the addition of variability into the R squared data? What was that one called? Good. Okay. Good. True or false? You can edit the custom algorithms inside SageMaker directly. True or false? If you want to bring your own algorithm, you must create your own Docker container. True or false? If you just want to wrap some code around an existing framework, you must bring your own Docker container. Good, that's false. Good. If you want to bring your own custom framework to SageMaker, you must bring your own Docker container. True or false? Good. Okay, that sounds great. Framework, MXNet, PyTorch, Chainer, that kind of thing. Yeah. Yeah, your own ML framework. Okay, sorry. Good. Okay. Are we feeling good to move on to the labs? You know, funny, Scikit is actually an importable library, but it is a framework that actually can do ML, right? So, yeah. Yeah. Scikit, we don't really use it at scale, but yeah, you can. Cool. Good. Okay. Seems like we're good. Okay. So let me just remind you, you just saw a bunch of concepts and this was your first time seeing them. You are not going to get them right off the bat. I know you might have understood it, but give it like 30 days and you're going to forget it. So I know I'm not knocking anybody. You're all intelligent people. Otherwise you wouldn't be here. I'm just saying that in general, you're going to want to revisit this material because these concepts are not like necessarily intuitively natural. And so you're going to want to refresh this and look at this again. Okay, this particular section out of almost any of these sections we looked at, because the other ones is like learning syntax. Like learning that Matplotlib and Seaborn are used for visualizations, that's easy. Learning that Scikit does, you know, a tremendous amount, but basically you can execute algorithms and it's used to manipulate and test data. Absolutely. Pandas being able to do data analysis, data exploration, and data manipulation. That's what Panda like focuses on. Pandas, and that makes total sense, right? Like that's easy to figure out. But these concepts like are less associative, right? So just make sure you come back and revisit these concepts and make sure you create mnemonics, you play with them, make your flashcards, draw and whatever, because once you do get the concept, you won't really have to come back and revisit it. So, I just want, of all the things that we've covered thus far, make sure you play with the concept of these metrics. Okay. Okay. Let's talk about the next lab. Hold on 1 second. Hold on just 1 minute. I need to change something here. Give me just 1 second. Dun, 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 dun. All right, complete the PE training, IPYMB, that's true. Review to break the practice exercise, that's not true. Let's see, you are gonna do that. You're gonna upload in the previous lab. Oh, yeah. Here's what I might do instead. I would upload your project file in there, complete the training PYMB. I would probably go rerun all of your tasks cells up to end of lab 2. Does everyone understand that you're going to have to rerun the tasks that you did in lab 2 in this new environment in order for you to have the zip files and all the pre-processing and all that done? Does that make sense to everybody? Okay. You're in a new environment. You downloaded your notebook. It has what needs to be done, but you're going to need to rerun it in order to make sure it runs. Now, the environments are identical. How do we know that? Because infrastructure is code for the win, right? Now, does it always provision consistently? Well, we found out yesterday that's probably not the case, right? But for the most part, it's pretty consistent, right? So that all being said, you're going to rerun all your cells up to the lab 2 in your project IPYMB, okay? Then you're going to go back and you're going to complete the training IPYMB, and then you're going to apply what you learned to complete the model training for your project, right? Yep. Moving on to model training and evaluation. Okay. Does this not make sense to anybody? Get things started, log in, upload your previous project file up into the environment, run through the cells. Remember, they should work. You haven't changed anything. I say should. Don't let that sound judgmental. If I've come across as judgmental, I apologize. Right? But they should work. It should be identical environment, right? And then stop at the end of lab 2, switch over to the training so you can get exposure to doing the model training setup and the model evaluation, and then apply what you've learned by continuing in your project file. Remember, you also have a solution here, but as we learned yesterday, do not run the solutions code in the solutions file, run it in the project file, okay? And then this is a general recommendation. You definitely want to put your student project file in the same folder that was in yesterday, which should be inside projects, right? So follow me there. You got it. And then save and download your work, your completed work at the end. Okay. It looks like a bunch of you, by the way, have already opened your labs, which is awesome. Please go do that. So log into webh.quicklabs.com, run through the setup, follow the instructions here. I'm going to leave these up, and that's what we're going to do. Now it says 120 minutes. Frankly, if it's okay with you, I'm going to give you the full 150 minutes or so. Okay. So we're going to spend 2.5 hours or a little less than 2.5 hours on this. I don't want you to feel pressure. I want you to be able to play around. While you're doing that, I'm going to post the book that I wanted you to look at later on. I'm going to post it. So for those of you who get done early and you're like, I've explored it and I feel really comfortable with all this, go take a look at the book that I posted into chat. Okay. If you have not done lab 2, which several of you just messaged me about it, you definitely want to run through lab 2 now, but just know that you might run out of time. So you want to move as fast as you can, leverage the solution code as much as you possibly can in your project notebook in order to move that forward. Okay. Let's see. Someone asked me where PE training was. Let's go take a look. I not? Let me see. Hold on. Let's see. John, PE dash training is and this is for everybody, right? Is right above the project and the solutions folder. So it should be right there at the kind of like home directory for the EC2 for SageMaker. So it should be right at the top there. Let's see, are we having to rerun the lab 2 in our environment because of how the lab environments is set up? Yes. So because we're cutting over from one lab environment to the next, normally you wouldn't have to rerun the cells. To be clear about this, if you had your notebook copied up to an instance and you ran the cells, all the files would actually be on the instance. If you left that instance up and running and you came back to it an hour later, all the data would still be there and you wouldn't have to rerun the cells. But because we moved from one virtual machine, stopped it, then moved to another virtual machine, that's why you have to rerun, right? So now that's not how I would have set this thing up. But now you get to learn how to download notebooks and re-upload them. Anyway, yeah, so there it is. Okay, good. Someone was asking me about, do we overwrite the existing notebook? You can, just to say this, I usually actually rename it to original or backup or some other name, and then I upload the notebook. So that's probably an actual great step, right? I'll put that on the sheet.